The last region of the periodic table that you need to learn about is a transition metal block. It's found between group 2 and 3 of the periodic table. Now these metals are not placed in these groups because they have different charges. Okay, so these metals circled are all common transition metals that you probably heard of. So things like iron, Fe, nickel, Ni, copper, Cu. We've got silver, gold, mercury. Most of these metals are solid. The one that is not is mercury here. So in this session, we're going to describe the properties of transition metals, link uses to the properties of transition metals, and finally compare the physical and chemical properties of transition metals with alkali metals. We know that most metals are solids, but when we draw the solid structure for a metal, the metallic lattice, we leave gaps in between the atoms. Now all metals are positively charged, so we represent the atoms with a positive charge, and we know that they've got a regular structure because they're solids. We have to add in these electrons. Now these electrons are added at random. We call these electrons delocalized electrons. They are free to move around. And because they're free to move around, they will carry charge throughout the structure of the metal. So all metals can conduct electricity. For the same reason, all metals are good at conducting heat, because heat can pass through their structure through their delocalized electrons. This metallic bonding can be described as positive metal atoms surrounded by a sea of delocalized electrons. Reactions between transition metals and things like water or acid are far less violent, far less vigorous than the reactions between alkali metals and acid or water. So let's have a look at what happens when we put hydrochloric acid and react it with some zinc. Now remember, when we added alkali metals to water, they were very violent. We add the zinc in, we can see that a few bubbles are being given off. Not many, but you can see a steady stream of bubbles given off. If it's a metal with acid, it will make hydrogen gas. So those bubbles coming off are hydrogen gas. If I put it closer, you'll see that there's bubbles actually on the metal surface as well. Okay, but it's far less vigorous and slow reaction compared to the fast reactions that alkali metals have. Another big difference between transition metal compounds and alkali metal compounds is that transition metal compounds are colored. The alkali metal compounds are usually white in color. Now, because transition metals form colored compounds, we can use them in paints and dyes. Okay, we know that iron forms green or brown precipitates, or green-brown colors. Copper forms a blue color. Manganese, pale pink. Nickel, pale green. Chromium, dark green. So if we want different shades of colors, we can use different transition metals. We can mix them together to make totally new colors as well. For some extended exam questions, they will ask you to compare group 1 elements with transition metal elements. Now we need to look at these specific properties. Hardness. In terms of transition metals, we have very hard elements because they have a strong electrostatic attraction between the positive and negative ions in their metallic lattice structure. That also gives them a high melting point, boiling point. Alkali metals do also have a metallic lattice structure, but it's not as compact or it's not as dense as the transition metal structure. So the hardness is higher, melting point is higher in transition metals compared to group 1 elements. Transition metals are also more useful than alkali metals. This is because of their reactivity. They react slowly with water and with oxygen compared to the vigorous reactions that alkali metals have with water or oxygen. The usefulness includes being used as catalysts for reactions, because they can be used again and again over a long time. And because of their strength, they're used in construction. Transition metals have different charges. We'll go on to that next session. Alkali metals have a charge of plus, a positive charge. Because they are all placed in group 1, they all need to lose one electron to get a full outer shell.